Okay, we're going to be looking at the last problem on your worksheet, and it's the problem about a monohybrid cross. A monohybrid cross, remember mono always means one. A monohybrid cross is going to be a cross that tests for just one trait. So a singular trait, we're going to be doing a monohybrid cross. So our problem talks about dogs, and it says, in dogs there is a hereditary deafness caused by a recessive gene, little d. A kennel owner has a male dog's name is Gilbert, that she wants to use for breeding purposes if possible. The dog can hear. What are the two possible genotypes for Gilbert? So earlier on your sheet I asked you what a genotype is, and a genotype is represented by letters. So if we're looking at genotype, there are also always three possibilities. There is homozygous dominant, which you're going to get both alleles being dominant. We represent homozygous dominant big D, big D. The second option is heterozygous dominant, where we'll have one dominant allele, big D, and one recessive allele. And then the third option is homozygous recessive, which is represented with two recessive alleles, so little d, little d. In our problem it says that Gilbert, the dog, can hear. So Gilbert is going to have a dominant trait. Deafness is represented by the recessive gene little d. So in order for Gilbert to hear, he has to have a dominant gene present. So if we look at homozygous dominant, big D, this is going to be a dog that can hear. Heterozygous dominant, we have big D, little d. The little d will be canceled out by the big D. This dog can hear. And the third one, homozygous recessive, little d, this one's going to have the recessive gene. This dog is going to be deaf. The two possible genotypes for Gilbert, since he could hear, would be big D, homozygous dominant, and big D, heterozygous dominant. Next it says, if the dog's genotype is big D, the owner does not wish to use him for breeding, so that the deafness gene will not be passed on. This can be tested by breeding the dog with a deaf female. Draw two possible Punnett squares to illustrate these two possible crosses. So let's start with the first one. To draw a cross, we need to first start a Punnett square, and in a monohybrid cross, we need a 4-box Punnett square. So it's a box with 4 little boxes inside. And up top here is going to go the alleles for usually your male. So Gilbert is the male. His alleles are going to go on top. So big D and little d. And over on the side, we're going to put the female's alleles. So it says that we're going to test Gilbert with a deaf female, little d. So her alleles are going to go on the side. Once you have your alleles written, all you have to do is fill in the boxes. And to do that, you just fill in down and across. So our big D is going to fill in down. Our little d is going to fill in down. This one's going to fill over. This is going to fill over. So this is a heterozygous dominant male crossed with a homozygous recessive female. And we get, as a result, we're going to have 2 heterozygous dominant and 2 homozygous recessive. These two dogs are going to be able to hear, these two dogs are going to be deaf. If we were to look at another situation, and let's say this time Gilbert, the male dog, is homozygous dominant. So he has both dominant alleles. And we breed Gilbert with the homozygous recessive female. When we do the cross, what we're going to see is now each box has just one possibility present. So we would have 4 big D, little d, 4 heterozygous dominant. All 4 of these dogs will want or will be able to hear. Okay, last but not least, it says, in each case, what percentage, how many of the offspring would you expect to be hearing or deaf? How could you tell the genotypes of this male dog? Also use it Punnett squares. Show how 2 hearing dogs could produce deaf offsprings. So let's break this problem down. There's a lot going on. So the first thing it asks is, in each case, what percentage, how many of the offsprings would you expect to be hearing? So in our first cross, when we crossed Gilbert with the female, wrong way, we got 2 hearing and 2 deaf. So for the first case, that's going to be 50% hearing and 50% deaf. In the second situation, we got all four dogs were heterozygous, so 100% could hear. So if we got dogs that all could hear, we would know that the genotype had to be homozygous dominant, so that all those little D recessive alleles were canceled out. The last portion of this question says, also, using Punnett squares, show how 2 hearing dogs could produce deaf offsprings. And I want to have 2 hearing dogs that could produce deaf offsprings. So in a Punnett square, I already know that if I have a hearing dog and a deaf dog, I will get all hearing dogs. If I have a hearing dog that is heterozygous and a deaf dog, I will get half hearing, half deaf. But I want to look at, if I have 2 hearing dogs, how can I get a deaf dog? So I'm going to try this, where I have a heterozygous female and a heterozygous male, and see what we get there. So I'm going to copy my D's down. And my D's across. And I see that I'm going to get 4 different options. The first one, I'm going to get 1 big D, big D. I'm going to get 2 big D, little d. And finally, 1 little d, little d. So in this situation, I'm going to have a 25% chance of being homozygous dominant and hearing, a 50% chance of being heterozygous, hearing, and a 25% chance of being homozygous recessive and not being able to hear.